Morning, my dear students. Welcome to Unacademy. Welcome to Kreatryx channel and welcome to Impulse batch. Before going to start today's session, let me introduce myself. I'm KV Swamy. I've done my MTech in Systems and Signal Processing, and my favorite subjects include Signals and Communication. And currently, I'm associated with Unacademy. And if you want to purchase any course on Unacademy, you can use my referral code KVS Live, with which you will be getting flat 10% discount. Any course on Unacademy you can purchase using the referral code KVS Live. First of all, we'll observe what are the various courses for GATE we are having in Unacademy. Basically, we are having two types of subscriptions, namely the Plus subscription and the Iconic subscription. In the Plus subscription, the student will be exposed to live classes, crash courses, weekly tests, doubt solving sessions, and batches are conducted in both English and Hindi mediums. If a student is not comfortable with English, he can take the batch in Hindi, and if a student is not comfortable with Hindi, he can take the batch in English from his favorite educator. And we have rank improvement batches as well. Coming to Iconic subscription, here a personal coach is allotted to every student who will prepare the study planner. Study booster sessions are there. Separate test analysis is taken for each and every student. Dedicated doubt clearing instructors are there, and preparatory study material is also given to the students. Coming to the fee structure, if a student is planning his GATE or ESE journey in Plus subscription for 12 months, that is 1 year program, this costs around 27,225 rupees only after applying the code KVS Live. GATE or ESE preparation in Plus subscription for 18 months, that is 1.5 year program, this costs around 34,650 rupees only after applying the code KVS Live. GATE or ESE preparation in Plus subscription for 24 months, that is 2 year program, this costs around 39,600 rupees only after applying the code KVS Live. Coming to Iconic subscription, GATE or ESE preparation in Iconic for 12 months, that is 1 year program, this costs around 45,225 rupees only after applying the code KVS Live. GATE or ESE preparation in Iconic subscription for 24 months, that is 2 year program, costs around 66,600 rupees only after applying the code KVS Live. And coming Sunday, that is on 27th of June, Unacademy is going to conduct Unacademy Combat for the branches of Mechanical, Civil, Electrical, Electronics and Communication, Computer Science and IT. And the advantage with this exam is, if your rank is in between 1 to 3, you will be getting 100% discount on Plus subscription. And if your rank is in between 4 to 10, you will be getting 75% off on Plus subscription. And if your rank is in between 11 to 50, you will be getting 50% off on Plus subscription. And if your rank is in between 51 to 100, you will be getting 25% off on Plus subscription. And these are the currently running batches. This batch called Laksha batch and Arohan, Laksha for 2022 and Arohan for 2023. EC aspirant has just started yesterday. You can take the subscription in this batch using my code KVS Live. And we have for electrical Laksha batch and Arohan batch, and this batch has also started yesterday itself. You can take admission into this batch using my code KVS Live, and there is a chance of increasing the subscription price in Unacademy. So I request all of you to take the subscription as soon as possible so that you can beat the price hike. And Unacademy is coming with a new feature called efficient revision via digital notes in its app. So if you take the subscription, you will have an advantage of this one also. Right. Good morning, Vamsi. Good morning, Fazal. Please confirm whether my voice is clear or not. After that, give your attendance by pressing the like button. All of you, give your attendance by pressing the like button. Am I audible? Please reply so that I can start the class. Yes, thank you. See, yesterday what we were discussing, I think we were discussing the convolution property of Z transform. So if I write that property, convolution in time, What does it say? It says that if the signal x of n forms a Z transform pair with x of z with ROC R1, h of n forms a Z transform pair with h of z with ROC R2, then x of n convolved with h of n forms a Z transform pair with x of z multiplied with h of z with ROC containing R1 intersection R2. And the statement we have seen is convolution in time domain is equivalent to multiplication in z domain, and here we have to take the common ROC. We have to take the common ROC, R1 intersection R2. And what is this h of z known as? This h of z, which we obtained by taking the z transform of impulse response, is known as transfer function. Transfer function. Right. Now we'll do one thing. We'll try to solve one question. It's a previous gate question given in 2014. Given, he said, y of n is equal to x of n convolved with g of n, where x of n is equal to 1 by 2 whole power n u of n, and g of n is a causal sequence. If y of 0 is equal to 1, y of 1 is 1 by 2, then g of 1 is asking us to calculate the value of g of 1. He gave the options 1, 1 by 2, 2. Try to solve this problem. Try to solve this problem. Good morning, motivation and amazing fact. Any answers? Ninety to 95% of the previous gate questions we'll try to solve in the class only. You can verify also. If you can go to the previous videos, many problems we are solving. Options are given A, B, C, D. What could be the answer? Suppose if you don't want to use this convolution in time property also, yes, you'll get the answer. There are many ways. Good morning, Adarsh. Any answer? A, B, C, D. Among A, B, C, D, what is the answer? Look here, how to solve this problem? How to solve this? Vamsi Krishna has said that answer is B. Vamsi Krishna answer is B. That is, he wants to say that answer is 1 by 2. Okay. Fazal Rasul, answer is D, means he is saying that answer is g of 1 value is 0. Okay, fine. Observe here. How to solve this problem? What is it? Yn is equal to xn convolved with gn. X of n convolved with gn, right? Now, what is xn? He said xn is 1 by 2 whole power n u of n. What is the z transform? X of z 1 upon 1 minus 1 by 2 z inverse. Now, what happens if I apply z transform? Y of z is equal to convolution in time domain is equivalent to multiplication in z domain. Hope this is clear. Now, substitute x of z. What will happen? 1 by 1 minus 1 by 2 z inverse multiplied with g of z. Now, what happens if we cross multiply? Y of z minus 1 by 2 z inverse y of z is equal to g of z. Now, what happens if you take the inverse z transform? G of z inverse is g of n, y of z inverse is y of n minus, using the shifting property, z inverse into y of z means y of n minus 1. Now, what value is asking? G of 1 value is asking. G of 1. So, it is nothing but substitute the value of n to be 1. Y of 1 minus 1 by 2 y of 0. Do you know what is the value of y of 1? Do you know what is the value of y of 1? I think he gave the values. Y of 1 is 1 by 2 he gave. 1 by 2 minus 1 by 2, y of 0 value is 1 he said. So, g of 1 is 0. So, option D is right answer. Option D is the answer. 0 is the answer. 0 is the answer. See, without application of this convolution in time property also you can get. Hope you remember the cross table method, what I told you. Cross table method. While discussing linear conversion, I told you, no, cross table method. Using that method also you can get the answer. How? Observe here. Y of n is equal to x of n convolved with g of n. X of n is 1 by 2 whole power n u of n. No, do one thing. Form a cross table. X of n is 1 by 2 whole power n u of n. So, n is equal to 0, 1, 1 by 2, 1 by 4 and so on. Now, g of n he didn't give any expression, but he simply said g of n is a causal sequence. Causal means we know that the signal is 0 for n less than 0. So, I don't know, I am assuming that signal, samples of that signal to be A, B, C, D, some A, B, C, D I am assuming. Now, what is asking? He is asking us to get the value of g of 1. G of 1 means this is g of 0. G of 1 means he is asking us to get the value of B. Get the value of B. Now, multiply and observe what happens. See, for g of n he said that it is a causal sequence. Causal sequence means the sequence must be 0 for n less than 0. I don't know the sample values, so I am assuming A, B, C, D. Yes, I can assume. Cross table method, hope you remember. Multiply. After that, A by 2, B by 2, C by 2, D by 2, A by 4, B by 4, C by 4, D by 4. Now, separate in a diagonal fashion. Like this. Now, what happens if separate? See, this is nothing but y of 0. Y of 0 is A, but what is the value of y of 0 he gave? He said that y of 0 is 1, implies A is equal to 1. Now, what is y of 1 from the cross table? A by 2 plus B. Y of 1 is 1 by 2 he said, or 1 by 2 is equal to A value is 1, 1 by 2 plus B, or B value is 0. That is what is asking. B value is simply 0. Yes, you can attend, Siddhas. You can attend. Not a problem. Hope this is clear. If you are not convinced with these two methods, you can go with folding, shifting and multiplying. With that method also, you will get the same answer. I'll verify Siddhas. I'll verify and let you know tomorrow. Siddhas. Okay. Let's solve one more previous gate question. In this question, he said h of z is nothing but h1 of z plus some r times h2 of z. The transfer function is given like this: h1 of z plus r times h2 of z, where mod r is less than 1, he said. And he added that h1 of z is 1 by 1 minus pz inverse, h2 of z is 1 by 1 minus qz inverse, p is 1 by 2, q is minus 1 by 4, and he said if 0 of h of z lies on the unit circle, if 0 of h of z lies on the unit circle, the value of r is, try to solve this problem. Try to solve this problem. Is asking us to calculate the value of small r. Is a previous gate question. Any answers? The value of small r is. This kind of questions only will come in the exam. Okay, let me solve this one. Meanwhile, if you get any answer, you can type your answer in the live chat. What is h of z? H of z is simply h1 of z, 1 by 1 minus 1 by 2 z inverse plus r times h2 of z. h2 of z is 1 by 1 plus 1 by 4 z inverse. Or if I simplify this one, what is that I am going to get? Z upon Z minus 1 by 2 plus R times Z upon Z plus 1 by 4, or H of Z is equal to, if you simplify, Z times Z plus 1 by 4 plus RZ times Z minus 1 by 2 upon Z minus 1 by 2 multiplied with Z plus 1 by 4. Hope everybody is comfortable up to this step. No problem. Here, what is that? 0 of H of Z lies on the unit circle. So, roots of the numerator in this transfer function will provide us the zeros, no? So, if you equate the numerator to 0, what will happen? For getting zeros, Z times Z plus 1 by 4 is equal to minus RZ times Z minus 1 by 2, right? Now, this Z I am cancelling, so that yes, what is that you are going to get? What is it, or what is R now? Here minus R is Z plus 1 by 4 upon Z minus 1 by 2. He said 0 of H of Z lies on the unit circle now. 0 of H of Z lies on the unit circle means substitute Z is equal to 1. Z is equal to 1. If I substitute, what happens? Substituting Z is equal to 1, as 0 is said lies on the unit circle, substituting Z is equal to 1, what will happen? So 1 plus 1 by 4 upon 1 minus 1 by 2, or this is 5 by 4 by 1 by 2, from which I am going to get the value of R as minus 2.5 or as minus 2.5, which is a wrong answer, because he said, strictly said that R must be less than 1, mod of R must be less than 1, but here what is the value of R I got? Minus 2.5. So this value of R minus 2.5 I got by assuming that the 0 lies on the unit circle, means I am assuming that Z is equal to 1. 0 lies on the unit circle means Z is equal to, at Z is equal to 1. Now in the next case, what I will be doing is, observe here, minus R, what is that I got here? Z plus 1 by 4 by Z minus 1 by 2. So what happens if I take Z is equal to minus 1? Z is equal to minus 1 I will take. So let's take Z is equal to minus 1, because Z is equal to 0 lies on the unit circle. So the 0 may be at minus 1 also. What happens if I substitute minus 1? So minus R is equal to minus 1 plus 1 by 4 by minus 1 minus 1 by 2, or minus R is equal to, what is that you are going to get? Minus 4 plus 1 minus 3 by 4 by minus 3 by 2, right, which is nothing but 1 by 2. So R value is minus 1 by 2. R value is minus 1 by 2. R value is minus 1 by 2. If I take the 0 location on Z is equal to 1, the value of R I am getting is minus 2.5, which is not satisfying with this condition. He said that mod R must be less than 1. So I changed. Instead of taking Z is equal to 1, take Z is equal to minus 1. Hope this is clear for all of you. Shall we go to the next problem? Shall we go to the next problem? Observe here. The next problem is like this. He said, consider a signal y of n which is related to two signals x1 of n and x2 of n by y of n is equal to x1 of n plus 3 convolved with x2 of minus n plus 1, where x1 of n is 1 by 2 whole power n u of n and x2 of n is 1 by 3 whole power n u of n. Find y of z, he said. Come on, try to solve this problem. Find y of z. All of you must try. Similar kind of problem we have done in Laplace also, while discussing the same convolution in time property. All of you try this problem. How to solve how to solve this problem? Y of n, first of all write y of n. Y of n is nothing but x1 of n plus 3 convolved with x2 of minus n plus 1. Now if I want to calculate the Z transform, the convolution in time property is saying that convolution in time domain is equivalent to multiplication in Z domain. So signals are convolved means Z transforms are multiplied. So what is the Z transform for x1 of n plus 3? Okay. First of all, let's find out Z transform for x1 of n plus 3. How we got x1 of n plus 3? First of all, we have our signal x of n. We shifted so that we got x1 of n plus 3. What is the Z transform for x1 of n? X1 of z, and using the shifting property, x1 of n plus 3 z cube multiplied with x1 of z using the shifting property, right? What is the other signal? x2 of minus n plus 1. Now how we get this relation? This is a transformation using shift. This is a transformation involving shifting as well as scaling. First shift, then scale. x2 of n is there with us. Go to x2 of n plus 1. Call this as some y of n. Scale this y of n by minus 1 so that you will get x2 of minus n plus 1. What is the transform for x2 of n? x2 of z. x2 of n plus 1 z times x2 of z using the shifting property. Now this is y of n whose z transform is y of z here. Y of minus n, y of minus 1. Reversal property yesterday we have seen, no, x of minus n forms a z transform pair with x of 1 by z, x of 1 by z, and ROC becomes 1 by r. Yesterday we have seen. So y of minus n, see y of n z transform is z into x2 of z. Y of minus n z transform would be, wherever you have z, replace it 1 by z. Z inverse into x2 of z inverse. So I got the z transform for x1 of n plus 3 and I got the z transform for x2 of minus n plus 1 also. So do one thing, substitute these two z transforms here. So x1 of n plus 3, z transform is z cube into x1 of z, x2 of minus n plus 1, z inverse into z inverse. Right, or this is z square into x1 of z multiplied with x2 of z inverse or 1 by z. Now z square x1 of z means 1 by 2 whole power n u of n, z by z minus 1 by 2, and x2 of 1 by z means in the z transform of x2 of n, wherever you have z, replace it with 1 by z. So 1 by z by 1 by z minus 1 by 3. You can simplify further. Good morning, Uber Johnny. Now observe here. What is the ROC? What is the ROC? See how to get the ROC. We know that for convolution we will take the common ROC. Now we have to find out the common ROC between x1 of n plus 3 and x2 of minus n plus 1. Let's find out. Now x1 of n, what is the ROC? See, x1 of z is z by z minus 1 by 2, no? So what is the ROC? Mod z greater than 1 by 2. With shifting there is no change in ROC, mod z greater than 1 by 2. So ROC for x1 of n plus 3 is mod z greater than 1 by 2. Then what about x2 of minus n plus 1? See, ROC for x2 of z. x2 of z is z upon z minus 1 by 3. Listen carefully. ROC is mod z greater than 1 by 3. Here shifting is done. With shifting there is no change in the ROC. Here reversal is done. Yes, ROC is for reversal. What happens here? ROC will be 1 by r, or 1 by mod z greater than 1 by 3, or mod z less than 3. Mod z less than 3. So you have to take the common ROC between these two, mod z greater than 1 by 2 and mod z less than 3. So the final ROC would be 1 by 2 less than mod z less than 3. One by 2 less than mod z less than 3. Here in the first one only shifting is done, so ROC will not change. In the second expression, shifting as well as reversal is done, no? With shifting, ROC is anyway not going to change. With reversal, ROC will change. ROC will become mod z less than 3 here. So for convolution, you have to take the common ROC between mod z greater than 1 by 2 and mod z less than 3. Common ROC would be 1 by 2 less than mod z less than 3, which I have written here. You can further simplify this y of z also as per the convenience. Idea is important. How to find out the z transform. Hope this is clear. Yes, we can simplify that z transform, we can simplify. See, thus you can simplify that y of z, not a problem. You can further simplify this y of z. Shall I go to the next problem? Reply is required. Okay. Next question. the following information is given about a discrete time LTI system. If x of n is equal to minus 2 whole power n, y of n is simply 0. And he added, if x of n is equal to 1 by 2 whole power n u of n, y of n is del of n plus a times 1 by 4 whole power n u of n. There are two questions. First question, find a, find the output if x of n is equal to 1 for all n. If x of n is equal to 1 for all n. Read the problem. Read the problem. He said that some information is given about a LTI system, that he's applying this kind of input, minus 2 whole power n, y of n is 0. And in the next case, he's applying this kind of input, x of n is 1 by 2 whole power n u of n. Then he found that y of n is del of n plus a times 1 by 4 whole power n u of n. And from this, he's asking find the value of a and find the output if x of n is equal to 1 for all n. How to approach this problem? Always remember, my dear students, whenever you are given these kind of signals where u of n, u of minus n minus 1, nothing is involved, always go for Eigenfunction property. Eigenfunction property. So Eigenfunction property means, look here, see, to be in a strict sense, you cannot find out the Z transform for this minus 2 whole power n. See, observe, you cannot find out the Z transform for minus 2 whole power n, because minus 2 whole power n, I can write it as minus 2 whole power n to u of n plus u of minus n minus 1. So there won't be any common ROC, so that I can find out the Z transform. For these kind of everlasting signals, I cannot find out the Z transform, but given these kind of signals as input, we can find out the output using Eigenfunction property. But what does this Eigenfunction property in Z transform say? See, Eigenfunction property we encountered in continuous time Fourier transform, discrete time Fourier transform, Laplace transform, now Z transform. Eigenfunction property says that if input to a LTI system, discrete time LTI system, is a complex exponential of this kind z power n, y of n is the same z power n multiplied with h of z. This is the Eigenfunction property in the case of Z transform. Try to remember this one, important one. If x of n is equal to z power n, y of n is z power n multiplied with h of z. Sir, how we got this one means using your convolution sum expression, in the place of input substitute x of n is equal to z power n, you will get this one only. That's not a big deal, right? Now, how to make use of this Eigenfunction property? But first of all, put stars to this one so that we can confirm that this is important one. Now, how to apply this Eigenfunction property to our problem? What is it? The first statement, if x of n is equal to minus 2 whole power n, he said that y of n is 0. Okay, fine. By using the Eigenfunction property, if x of n is equal to minus 2 whole power n, what could be y of n? In the place of z, I have minus 2 now. In the place of z, I have minus 2. So y of n is the same minus 2 whole power n multiplied with h of minus 2, which must be equal to 0, which must be equal to 0. So because he said y of n is 0, now from this we notice that h of minus 2 is 0. H of minus 2 is 0. So h of minus 2 is 0 means what we have to do? First of all, look here, how to get this h of z? How to get h of z, the transfer function? In the second case, input is there. Look here, input is there, output is also there, from which you can find out the transfer function h of z, and in that h of z, substitute the value of z to be minus 2 and equate it to 0. Then you will get the value of a. So how to get this h of z? Look here, x of n is what is said in the second case, 1 by 2 whole power n u of n is said. From this, what is x of z? Z by z minus 1 by 2. Y of n, what is it? I think del of n plus a times 1 by 4 whole power n u of n is it. So what is y of z now? 1 plus a times z by z minus 1 by 4. So h of z is y of z by x of z, and from the first one we got this condition of h of minus 2 must be 0. So substitute the value of z to be minus 2 and equate it to 0. You will get the some value of a and tell me what is that value. Come on, do it and tell me what is the value of a you are going to get. See, from the first statement I got this condition that h of minus 2 must be 0. So I got this h of z from the second statement, transfer function I got from the second statement. Now I am using h of minus 2 is equal to 0. In this process you tell me what is the value of a you are going to get. All of you must solve this one. Tell me what is the value of a. Any answer? Harish, Fazal, Ubar, Jani, Pranay. Please verify, Pranay, you have done a small mistake. Chota mistake you have done. Pranay Gold. Chota mistake you have done. You are almost done, Pranay, but a small mistake. Anybody got this answer minus 9 by 8? See the 7 by 8. No, 7, not 7 by 8. Yeah, minus 9 by 8. Anybody got this answer as minus 9 by 8? Yes, Pranay, minus 9 by 8 is the answer. Right. Now, the first part is completed. What is second part? Find a, completed. Find the output if x of n is equal to 1 for all n. Find the output. S. Vamsi Krishna, very good. Find the output if x of n is equal to 1 for all n. Again, you have to use the Eigenfunction property only. Now, if I ask you one question that, can you find out the Z transform for 1? No, I cannot find out the Z transform for 1 because 1 can be written as u of n in discrete, u of minus n minus 1. ROC for u of n is mod z greater than 1. ROC for u of minus n minus 1 is mod z less than 1. I cannot find out the Z transform for this DC signal 1, but given these kind of signals as input to a discrete time LTI system, I can find out the output using what? Eigenfunction property. And what is your Eigenfunction property in Z transform? Saying if x of n is equal to z power n, y of n is the same z power n multiplied with h of z. Hope everybody remember the definition of Eigenfunction also. An input for which output is some constant time, the same input is known as eigenfunction, and the corresponding value what you are going to get is known as eigenvalue. We made a lot of discussion on this eigenfunction and eigenvalues. Please go through the previous videos if you are not unable to recollect. Now 1 can be written as 1 power n. 1 can be written as 1 power n. So what happens to my y of n? Y of n is the same 1 power n multiplied with h of 1, or y of n is h of 1. So how to get this h of 1? Substitute the value of a here, minus 9 by 8, so that your transfer function will be completed. In that, substitute z is equal to 1. So this is nothing but what is that you are going to get? Tell me. What is that you are going to get? Y of n. We must be very careful. Sometimes these kind of problems are also expected. Exactly, minus 1 by 4, right answer. Minus 1 by 4, right answer. See, before going to the next concept, I want to give you a previous IES question, ESE question, small question. After that, we'll go to the next concept. He said, he has taken a system, small question you can easily solve. Input x of n, output is y of n. He said that x of n is equal to k times del of n. Y of n, and he said y of n minus 1 by 2 y of n minus 1 is x of n. From this, he is asking what is the value of y of n. Assume y of n is 0 for n less than 0. Simple question. Here, do one thing. LTI system you take. Simple question. Y of n minus 1 by 2 y of n minus 1 is x of n, no? This is called a difference equation. Now applying Z transform, y of z 1 by 2 z inverse is equal to x of z. X of n is k del n. Now what is my y of n? Here what is said? Y of n is 0 for n less than 0 is said, means y of n is a causal. Y of n is causal, means k times inverse will be 1 by 2 whole power n u. Pranay, what happened? K times 2 power n. K times 2 power n, how you got here? Please verify. See, exactly. See, these kind of difference equations can be solved using other method also, but I'll tell you how to solve using other methods. Y of n, what is that he gave? Minus 1 by 2 y of n minus 1 is what? X of n, no? What is y of n? X of n plus 1 by 2 y of n minus 1. If I substitute the value of x of n, what is the value of x of n he gave? K del n, no? K del n plus 1 by 2 y of n minus 1. And he said that assume y of n is 0 for n less than 0. So what happens if I substitute n value to be 0? N value to be 0, what will happen? K times del of 0 plus 1 by 2 y of minus 1. Del of 0 value is 1, no? And y of minus 1, he said that y of n is 0 for n less than 0. So this is k. Y of 1, if I substitute the value of n to be 1, k times del of 1 plus 1 by 2 y of 0. 1 by 2 y of 0. So k times del of 1, del of n exists only at n is equal to 0, del of 1 will be 0. So this is 1 by 2 y of 0. Y of 0 means it is carried from the previous output k. What happens if I substitute the value of n to be 2? N to be 2, k times del of 2 plus 1 by 2 y of 1. So del of 2 means del of n exists only at n is equal to 0. So del of 2 will be 0, 1 by 2 y of 1. Y of 1 comes from the previous output. Always remember here, the output at any instant is depending on the previous outputs. Previous outputs means 1 by 2 k. This is 1 by 2 whole square into k. Suppose if I substitute k is equal to n is equal to 3, k times del of 3 plus 1 by 2 y of 2. This is 1 by 2 whole square into this is 1 by 2 whole cube into. Now can you generalize your output? See, for n is equal to 0 I got k, for n is equal to 1 I got 1 by 2 whole power k, 1 by 2 k, for n is equal to 2 I got 1 by 2 whole square, for n is equal to 3 1 by 2 whole cube, in general and so on. Output will be 1 by 2 whole power n, 1 by 2 whole power n, and as we are starting from 0, u of n. Hope you understood. See here, I want to say one point that, look here, when if you notice in the second method, what we are solving here, in the second method, the output at any instant is depending on the previous outputs. The output at any instant is depending on the previous outputs. So if you have this kind of system where output depends on the previous outputs, it is known as recursive system. It is known as recursive system. If output of a system depends on previous outputs, then it is known as what? Recursive system. Recursive system. While discussing digital filters, you might have studied IIR filters are recursive, whereas FIR filters are non-recursive. Anyway, for knowledge sake, remember IIR filters, infinite impulse response filters, are recursive. IIR filters are recursive. For electrical students, not required. For EC students, you can remember that IIR filters are recursive, whereas FIR filters are non-recursive. Output is depending on the previous outputs. Hope this is clear. Okay. If time permits, we'll have a discussion on the digital filters. What are recursive, what are non-recursive, what are the generalized expressions, how to get the impulse response, and all we'll see. Fine. The next discussion is how to determine the type of filter from the pole zero plot. How to determine this is an important discussion, the type of filter from pole zero plot. Very, very important discussion for EC students, electrical students, IN students, for everybody. It's an important topic. Okay, this statement is widely asked in interviews. Yes, Pranay, and we have a lot of discussion, Pranay. See, around half an hour discussion we can make on that recursive nature of the filter. Okay, how to determine the type of filter from the pole zero plot. Observe here. See, we have studied discrete time Fourier transform. Previously, before Z transform, we studied discrete time Fourier transform, where there also we found out the type of filter. What you did, you substituted three values of omega. What are those? Omega is equal to 0. Omega is equal to 0 corresponding to omega is equal to 0 is substituted corresponding to low frequency gain. Omega is equal to pi you substituted corresponding to high frequency gain, and omega is equal to pi by 2 you substituted corresponding to mid frequency gain. Okay, Mayank, I am not on plus, Mayank. So now this is DTFT, discrete time Fourier transform. Now we are in Z transform. Now how you are going to map? And in the introductory part of Z transform, if you remember, I told you one statement that Z transform converges to discrete time Fourier transform on the unit circle. Z transform converges to discrete time Fourier transform on the unit circle, or that is, if I substitute Z is equal to e power j omega, if I substitute Z is equal to e power j omega in my Z transform, it will become discrete time Fourier transform. So we can say that Z transform converges to discrete time Fourier transform on the unit circle. Now how you are going to get the values of Z corresponding to the values of omega? Now look here, substitute these three values. So in Z domain, if I want, so substitute omega is equal to 0. If I substitute omega is equal to 0, Z is equal to 1. So if you want low frequency gain from the transfer function or from the pole 0 plot, substitute z is equal to 1. And look here, if I want the mid frequency gain, substitute omega is equal to pi by 2. What will happen? Z is equal to j. And if I want the high frequency gain, z is equal to -1. So the corresponding values in z domain for low frequency gain are substitute z is equal to 1, mid frequency gain is z is equal to j, and high frequency gain z is equal to -1. If you are comfortable with these three, then we can proceed with the problems. Right. Now how you are going to look at the problem? Suppose if you are given a pole 0 plot like this, a simple pole 0 plot is given, and you are asked to find out the type of filter. I think you are aware we can have a low pass filter, high pass filter, band pass filter, band stop filter, and all pass filter. Okay. Suppose if you are given a simple pole 0 plot like this. Where I have a 0 at z is equal to 0 and pole is on the real axis between 0 and 1. Right. Now I want to know the type of filter. Here I want to know the type of filter. So this pole 0 plot corresponds to a transfer function. This pole 0 plot corresponds to a transfer function. Now I want to determine what type of filter is this one. So for that, first of all, get the transfer function. Transfer function means denoted by h of z. It will have DC gain k. Transfer function will have DC gain k. 0 is located at what? 0. So z. Pole is located between 0 to 1. So say it is 1 by 2. Pole is located 1 by 2. Now this is my transfer function. See, in my transfer function, if I want to get the low frequency gain, find out this one, magnitude of h of z at z is equal to 1. What happens if I substitute z is equal to 1? Z is equal to 1, if I substitute, what will happen? 2k. Right. Now high frequency gain you calculate, magnitude of h of z at z is equal to -1 you calculate. So what will happen? I think it will be 0.666k. Now if you compare, low frequency gain is more than high frequency gain, means what is your conclusion? Your conclusion is that the given pole 0 plot corresponds to a low pass filter. Low pass filter. The gain at low frequency is more than gain at high frequency, means it must be a low pass filter. And my dear students, I have one more approach in which you can find out the type of filter. I'll tell you later, not in this class, but that requires some analysis, but you will enjoy that method. Suppose if I give you a pole 0 plot like this, if I give you a pole 0 plot like this pole 0 plot corresponds to a transfer function. Now can you tell me what is that filter? What is the filter? This is real part of z, imaginary part of z. Now I want the type of filter. First of all, get the transfer function. Transfer function means DC gain it will have, 0 is located at 0, pole is located -1 by 2, z plus 1 by 2. Now low frequency gain. Low frequency gain, what is that you are going to get? 2 by 3 means 0.666k. High frequency gain, substitute z is equal to -1. What is that you are going to get? 2k. So here high frequency gain is more than low frequency gain. So what kind of filter is this one? This is a high pass filter. The gain at high frequencies is more than the gain at low frequencies. High pass filter. Okay. Now I am giving you one more pole zero plot. Now it's your turn to tell me the type of filter. Come on. Tell me what type of filter is this one? दिनेश मौर्य, मुझे तो पता नहीं है यार, मैं लेकिन पता करके आपको बोल दूंगा कल तक। इसी क्लास में कल आ जाइए आप, मैं कल आपको रिप्लाई दे दूंगा। मुझे तो जानकारी नहीं है अब। Now what type of filter is this one? Exactly, Siddhas, you are right, man. H of z is k times z minus 1 by z minus 1 by 2. Low frequency gain. Low frequency gain is how much here? 2k. Low frequency gain is how much? 2k, right? And what is high frequency gain? High frequency gain. Sorry, low frequency gain is 0 here. Is exactly. You're right, Pranay. Low frequency gain here is 0. High frequency gain, what is that you are going to get? Four by 3k. So high pass filter. High pass filter. Exactly, exactly. Now I'll give you one more. I'll give you one more pole zero plot. Mind me if my unit circle is not in a proper way. Real part of z, imaginary part of z. Here the poles and zeros are located. Come on, what type of filter is this one? What type of filter? Get the transfer function first. H of z is equal to k times 0. One 0 is located at 1, the other 0 is located at minus 1. One pole is located at j and the other pole is located at minus j. Isn't it? This is h of z is k times z square minus 1 by z square plus 1. Z square minus 1, low frequency gain is 0, high frequency gain is also 0. Low frequency gain is 0, high frequency gain is 0. Then you have to calculate the mid frequency gain. Look here, low frequency gain is 0. Magnitude of h of z at z is equal to 1 is definitely 0. High frequency gain, magnitude of h of z at z is equal to minus 1 will also be 0. Now mid frequency gain you calculate. Z is equal to z, which will not be equal to 0. So between low frequency and high frequency, one frequency is passed, means one band of frequencies is passed, means this corresponds to a band pass filter. Band pass filter. Band pass filter. Band pass filter. Suppose if I give you the pole zero plot like this, hope you're all comfortable with this one. See, this point is 1. This point is 1. See, z is equal to e power j0. This is z is equal to e power j pi by 2. Radius is 1, angle is pi by 2, no, e power j pi by 2. So it is j. This is z is equal to e power j pi. E power j pi. So it is minus 1. Right? It is z is equal to e power j 3 pi by 2. So it is minus j. Minus j. Suppose if I give you a pole zero plot like this, real part of z, imaginary part of z, come on, what is this filter, tell me? Poles, where are they located? This is h of z is equal to k times z square minus 1 by z square plus 1 by 4. Yes, this is also band pass filter because low frequency gain is 0, high frequency gain is also 0. So if I substitute z is equal to j and if I take the magnitude, this will not be equal to 0. So this also corresponds to a band pass filter. Band pass filter. What is this filter? K times, at origin I have two poles, z square, sorry, z minus 1 into z plus 1 by z square. Yes, this is also a band pass filter. Band pass filter. Let me give one more pole zero plot. Come on, tell me what is this filter? Assume that this is 0.5, this is minus 0.5. What is this filter? Kshitij, I am good. Band pass filter. Arey yaar, what is the transfer function? H of z is equal to k times 1 0 at j, the other 0 at minus j, one pole at j by 2, the other pole at minus j by 2. Or h of z is no Siddhas k into z square plus 1 on 1 by 4. Come on, what is this filter? All pass filter. Arey yaar, observe here. Magnitude of h of z at z is equal, low frequency again I am calculating. So k times what is this one? 2 by 1 plus 1 by 4, 3 by 4. Sorry, 5 by 4. This is what I am going to get. This is low frequency gain. High frequency gain you calculate. The same thing you are going to get. Right? Now, if I calculate the mid frequency gain, what will happen? This will be 0. This will be 0. Come on. What is this filter? Tell me. What is this filter? One band of frequencies is stopped. Means this corresponds to a band stop filter. Band stop filter. Band stop filter. Hope this is clear. Band stop filter. Mid frequencies are not passed. Means this corresponds to a band stop filter. Band stop filter. Suppose if I give you the next polar plot like this. Come on, what type of filter does this polar plot represent? z minus 2 upon z minus 1 by 2. Low frequency gain. What will happen? 2k, 2k, high frequency gain. What is that you are going to get? 2k again. Mid frequency gain you calculate. This will also be 2k. Now all the frequencies are passed with the same gain. Means what could be this filter? What could be this filter? This is an all pass filter. When all the frequencies are passed with the same gain, it denotes an all pass filter. All pass filter. See, here we have to make one statement that, very important statement. Here, where is the pole located? The pole is located at 1 by 2, and where is the 0 located? At 2. Means poles and zeros are forming reciprocals. So I can give a statement like this. Very important statement. In a all pass filter, with real poles. Real pole is real, no? With real poles, poles and zeros are reciprocals. Poles and zeros are reciprocals. And with complex poles, suppose where poles are complex, poles and zeros form reciprocal conjugates. Poles and zeros form reciprocal conjugates. Very important statement. Transfer function also the same procedure you have to follow thus. Same thing, substitute z is equal to j and take the magnitude, you will get 2k only. If you have real poles, poles and zeros are reciprocals, and if you have complex poles, poles and zeros form reciprocal conjugates. See, based on this statement, a previous GATE question was given like this. He said, given h of z is equal to z inverse minus b by 1 minus a z inverse, comma, magnitude of h of e power j omega is equal to 1 for all omega, he said. Real part of a not equal to 0, real part of b not equal to 0, then b equals, he said, a, options also he gave, try to solve this one. He has given a transfer function h of z, z inverse minus b by 1 minus a z inverse. He said magnitude of h of e power j omega is equal to 1 for all omega. real part of a not equal to 0, imaginary part of a not equal to 0, then B equals. Now how to solve this problem? Listen carefully. I am going to explain this. Here, among the statements he gave, magnitude of h of e power j omega is equal to 1 for all omega. Magnitude of h of e power j omega is 1, means the magnitude of frequency response is 1 for all frequencies, means it's constant for all frequencies, means from this we can know that the given filter is all pass filter. Magnitude of h of e power j omega is equal to 1 for all omega. All the frequencies are passed with the same gain, means this is an all pass filter. So this transfer function h of z, this transfer function h of z corresponds to a all pass filter. Now all pass filter transfer function is given, means first of all we must know the nature of poles, because I have given the statement here. If you have real poles, poles and zeros are reciprocals, and if you have complex poles, poles and zeros form reciprocal conjugates. So let's find out the poles and zeros. Poles, zeros. Remember, if you want the poles, poles are given by the roots of the denominator, right? So if I calculate the pole, or here you can say that the coefficient of z inverse indicate the pole. So pole is located at z is equal to a. Pole is located at z is equal to a. And what is the nature of this pole? Observe here, pole is located at z is equal to a. What is the nature of this pole? He said real part of a not equal to 0, imaginary part of a not equal to 0, means poles are complex. Poles are complex. See, he said that here pole is located at a, but real part of a not equal to 0, imaginary part of a not equal to 0, means the pole what I am going to get is nothing but not a real pole, it is a complex pole. Complex pole. And where is the 0 located? 0 is located 1 by b. 1 by b. And we have seen that if you have complex poles, poles and zeros form reciprocal conjugates. Poles and zeros form reciprocal conjugate. Reciprocal conjugate means if I have a pole at z is equal to a, a, 0 must be at z is equal to 1 by a star. Poles and zeros must be reciprocal conjugates. Poles and zeros must be reciprocal conjugates. If I have a pole at z is equal to a, and this is complex, means I must have a 0 at z is equal to 1 by a star. But from the transfer function, we got the 0 to be at 1 by b. So I can equate these two. 1 by b is equal to 1 by a star, or b is equal to a star. B is equal to a star. B is equal to a star. Or you can go in the other way also. See, as the pole is complex, look here. Now if I have a 0 at 1 by b, means what? Corresponding to this pole must be at reciprocal conjugates, no? Reciprocal conjugates. But I got the pole to be at a. So I can equate these two also. B star is equal to a, or b is equal to a star. Option C becomes the answer. Hope this is clear for all of you. Puzzle. Poles and zeros form reciprocal conjugates. Clear? If poles are real, poles and zeros are reciprocals, as in the previous case. Now, if your poles are complex, means poles and zeros form reciprocal conjugates. Remember, very, very important. Right. Suppose if I give you a previous gate question was given like this. He has given impulse response. Impulse response. The impulse response is 5 del n minus 7 del n minus 1 plus 7 del n minus 3 minus 5 del n minus 4. Now it is asking us to get the type of filter. It is asking us to get the type of filter. What you are going to do? Find out the transfer function. From that you can calculate the low frequency gain, high frequency gain, mid frequency gain. But how to find out the transfer function? We know that in discrete impulse response and transfer function they form a Z transform pair, or Z transform of impulse response gives transfer function. H of Z is equal to 5 minus 7Z inverse plus 7Z power minus 3 minus 5Z power minus 4. Come on, tell me the type of filter. Low frequency gain 5 minus 7 plus 7 minus 5. 0. Low frequency gain is 0. High frequency gain 5 plus 7 minus 7 minus 5. Find out magnitude of H of Z at Z is equal to J. Mid frequency gain, this will not be equal to 0. So this must be a band pass filter. Band pass filter. Clear? One more question we'll solve. Now I want the type of filter. What type of filter is this one? What type of filter? Sometimes this kind of realizations also can be given. Basically this realization corresponds to a FIR filter. See here how to get, first of all let's get the input output relationship. X of n when passed through a unit delay, X of n minus 1, X of n passed through a unit delay, X of n minus 2. This is the gain. If I multiply this X of n minus 2 with 5, 5x of n minus 2. X of n multiplied with 5, 5x of n. So your y of n is simply y of n is simply 5x of n minus 5 x of n minus 2. So get the transfer function. Transfer function is what? Yz by xz. Yz is 5x of z minus 5 using a shifting property z power minus 2 into x of z. Or your transfer function h of z is nothing but 5 times 1 minus z power minus 2. low frequency gain you calculate 0. High frequency gain you calculate 0. Mid frequency gain you calculate, which will not be 0. So this is a band pass filter. Band pass filter. Band pass filter. Yes, Siddhas, you are right. And remember, this is nothing but an FIR filter realization. FIR filter, finite impulse response filter. How do you know that finite this FIR filter means? FIR filter, finite impulse response, means in this in the impulse response of this filter we must have finite number of samples. So let's find out the impulse response. Impulse response means what? Input is the impulse signal. So impulse response, if I calculate h of n, so give the input as impulse signal 5 del of n minus 5 del of n minus 2. Now if you try to represent this in the form of a sequence, so I have a sample value at del n means exists at n is equal to 0 and the sample value is 5. Del of n minus 1 I don't have, del of n minus 2. So impulse response here is containing only 3 samples, finite number of samples, which corresponds to FIR filter. If the impulse response contains infinite number of samples, IIR filter. Suppose if my impulse response takes the form U of n. U of n, in U of n how many number of samples are there? Infinite number of samples are there. So this impulse response corresponds to IIR filter, infinite impulse response filter. And FIR filter and IR filter, they come under the classification of digital filters. Okay, that's all for today's class. Tomorrow we'll discuss some more properties of Z transform, and we'll try to solve some more previous gate questions. Hope you enjoyed this class. Yes, my dear students, these are the channels available in Unacademy. This is our channel, Kreatryx channel, and inform your friends regarding the channels available. And you can follow me on Unacademy, unacademy.com at kvswamy. And finally, thank you. Like the session, share the session, subscribe the channel if you are not subscribed till now, and press the bell icon so that you will get regular notifications on the ongoing classes. Okay. So tomorrow we'll discuss the accumulation property of Z transform followed by unilateral Z transform, and we'll see how to solve the difference equations using Z transform. After that we'll discuss the causality and stability of a discrete time LTI system. How to reduce silly mistakes? With practice only mistakes will be reduced, Siddhas. If you are getting silly mistake means don't worry, you are going in the right way only. You are following. With practice, your learning curve will converge. Okay, tomorrow we'll meet. Definitely. No limits. I think you are, I don't know whether your reason is genuine or not, but keeping that in mind, if you study, you will get not only this gate, you will get anything in life. Please remember. Thank you.